Have you ever wondered if time passes at the same rate for everyone, everywhere? It's a puzzling question, isn't it? This very conundrum sparked the idea of time dilation and the twin paradox. You see, time might not be as constant as we've always believed. Albert Einstein, the legendary physicist, hinted at this in his theory of relativity. So with that thought, let's plunge into the less traveled roads of physics. Now let's dive into the fascinating world of time dilation and the twin paradox. Imagine two twins, Alice and Bob. Alice decides to embark on a journey to a distant star at near light speed, while Bob stays on Earth. Now let's delve into this journey. Alice's spaceship is a marvel of engineering, capable of speeds that defy our everyday understanding. It whizzes through the cosmos, faster than anything we've ever seen. Here's where Einstein's theory of relativity comes into play. It tells us that as Alice approaches the speed of light, something extraordinary happens. Time begins to slow down for her, but for Bob back on Earth, time ticks along as normal. With each passing moment, a fascinating disparity emerges. A minute for Alice is not the same as a minute for Bob. The clock on Alice's spaceship ticks slower, her heart beats slower, and even her thoughts seem to take a leisurely pace. When Alice returns home, she would find that Bob has aged more than she has. This is time dilation. But here's where things get tricky. From Alice's perspective, isn't it Bob who's moving and she who's stationary? This question brings us to the heart of the twin paradox. You see, if we look at things from Alice's viewpoint, it's Bob who's zipping around at near light speeds. So shouldn't he be the one aging slower? Now, this seems to contradict the first part of our story, doesn't it? We've been saying that it's Alice who ages slower because she's moving, but now it seems like it should be Bob. It's a bit like a cosmic game of he said, she said, and that's where the paradox in Twin Paradox comes from. But let's not get too lost in this rabbit hole just yet. There's a crucial detail to consider. Remember, Alice took a spaceship, zipped around the galaxy, and then returned to Earth. That means she accelerated when she left, decelerated when she turned around, and then accelerated again to come back. Bob, on the other hand, just sat around on Earth, probably binge-watching his favorite show. He didn't experience any acceleration or deceleration. And this, my friends, is the key to our paradox. So, who ages more, Alice or Bob? The answer lies in the fact that Alice's journey involves acceleration and deceleration, which breaks the symmetry of the situation. It turns out, Alice's acceleration and deceleration play a key role in resolving the paradox. Imagine this. As Alice rockets away from Earth and then decelerates to turn back, she's experiencing shifts in speed and direction. This is where Einstein's special theory of relativity comes into play. The shifts in speed and direction, the acceleration and deceleration, lead to Alice experiencing time dilation, not Bob. You see, according to Einstein, it's not just speed that affects time, but also gravity and acceleration. So while Bob, who's been stationary on Earth, has been ticking along at his usual pace, Alice, moving at high speeds and experiencing changes in motion, finds her clock ticking slower. This is time dilation, and voila, the twin paradox is resolved. It perfectly aligns with Einstein's theory. It's not a contradiction, but a beautiful affirmation of the relativity of time. In the end, it's Alice who is younger when she returns home to Earth. So, what have we learned about time dilation and the twin paradox? We've journeyed through the universe of time, discovering that it can slow down or speed up, depending on our velocity and the gravity around us. This is the phenomenon we call time dilation. We've also grappled with the twin paradox, a seemingly contradictory conundrum where one twin journeys into space and returns younger than their earthbound sibling. It's a head-scratcher, isn't it? But when we factor in acceleration and deceleration, the paradox unravels. The traveling twin experiences different rates of time due to the effects of their motion. These concepts challenge our everyday understanding of time, stretching it and warping it in ways we would never experience in our daily lives. But that's the beauty of science. It continually pushes the boundaries of our knowledge. Next time you look at your clock, remember, time isn't as straightforward as it seems.